Hello, so today we are going to do this problem called the diagonal traverse, and the problem says that we get a matrix of m rows and n columns, and we wanna return all the elements of the matrix in a diagonal order, so that diagonals alternate from going up and down. So what this means essentially is that we will get a matrix like this, and we want to get all the diagonals, but such that we start from up, going up, the diagonal going up, and then we alternate to going down. And we return a list or an array of all of the elements with this order. So for example, in this matrix, we go up first, we take the first diagonal going up, then we alternate, so we go down, so we take the diagonal after that going down, so 2, 4. Then we alternate, so we take the diagonal after that going up, so 7, 5, 3, as you see here. And then we alternate to go down, so we take 6 and 8. And then we alternate going up, we take 9. And so this is the problem that we are trying to solve. Now let's see how we can solve it. Okay, so let's try to understand this problem a little bit more so we can solve it. So the first thing we can see here is that I just wrote down what we are looking for. So we want the first diagonal up, the diagonal after that going down, the one after that going up, and then going down, then going up. So we alternate the direction of the diagonal as we go. And so if we look at this, then if we take these diagonals here in this order, we will get 1 from the first diagonal. The second one going down, so we need to get 2, 4. The one after that going up, so 7, 5, 3. And then the one after that going down, so alternating again, 6, 8. And then going up, 9. So this is the result we are looking for. Now we can make a couple of observations that are known about diagonals. So if we take this 0, 1, 2, just the indices here, mark this with these indices. So the first diagonal has the coordinates 0, 0, right? The second diagonal has the coordinates 0, 1. But if we let's take the order of the coordinates that is indicated. So the second diagonal is going down, and so it starts out with 0. So it starts out with the 0, 1. And then after that we get 1, 0. If we take the third diagonal, which is going up, so it starts from 7. For that one, we start with 2, 0, and then we get 1, 1, and then we get 3, which is 0, 2. If we take a look at, we will find a pattern here of how we are walking through the diagonals very soon because of this. And so for the fourth diagonal, we will get the first, so the fourth is going down the fourth diagonal. So the first element is 6, which is 1, 2. The second element is 8, which is 2, 1. And then the last diagonal here is just 2, 2, right? Okay, so let's make a couple of observations here. If we consider these to be ij, the coordinates for each element here, so taking ij here, we can make some observations. So for example, here I plus j is equal to 0, and here for I plus j for this one is 1, and then I plus j for the second one is 1. So for both I plus j are equal to 1. For this one, I plus j for the first one is 2, for the second one is 1 plus 1, 2 as well. For the last one, 0 plus 2, 2 as well. So I plus j is always 2 in this element as well. Here, I plus j, 1 plus 2 is 3, 2 plus 1 is 3, so also I plus j is always 3. Here, 2 plus 2 is 4, I plus j is always 4. And this is basically a property of all the diagonals in this direction, is that I plus j's are the same for every diagonal. So this is our first observation here, is that I plus j is the same for each diagonal. And then now if we take a look at the order here, so this is going up, so this is one value, we don't get much, but for the second one that is going down, we can see that I is the smaller element. For the one where it's going up, I starts out to be the bigger element and then decreases. So what this would mean here is that going down, so going down means that I is increasing, and then j is decreasing. And then if we take a look at this one where we are going up, right, 753, well, for that I is going down from 210, and then j is 012, so it's going down. So I is increasing, and then j is decreasing. Let me just put it here with an arrow. For this one, the fourth diagonal, which is down, well, we start from 1 and go to 2, and then for j we start from 2 and go to 1. So it's the same as going down before. So I is increasing and j is decreasing. This one is one value, but if we had more values, we will find the same pattern. So the second observation that we can make here is that I is when going up, so when direction is up, I is increasing and j is decreasing. And then when diagonal direction is down, then I is, I made a mistake here, I is decreasing here, because 2, 1, 0, so I is decreasing, and j is increasing. And then the reverse one is down. So this here, I is decreasing, and j is increasing. That's what we see here. J's goes from 0 to 1 to 2, so it's increasing. So this is when we are going up. When we are going down, you can see I is increasing, right, 0 to 1, and then j is decreasing. So just the reverse here. Right? Okay, so this is one thing to know. Now, another observation we can make is that, well, what is the sum each time? So here, let's take another color. So I plus j here is equal to 0. I plus j here is equal to 1. So it is odd. And here it is even. And here I plus j is equal to 2 is even. And here I plus j is equal to 3 it is odd, right? And here I plus j is equal to 4, so it is even, right? So one observation we can make also, if you explore more matrices of longer length, you will find this to be true, which is when I plus j is even, we will be going up. So this one is going up. And when it's odd, we go down. We are going down, right? So every time it's even, we go up. Like for example, here it's even, here it's down, it's odd, down, odd, right? So this is another observation that will help us solve the problem. So observation 3, when I plus j is even, direction is, so even here direction is up. And since we alternate, so it's because the first diagonal is up, and we start out with the first diagonal sum is even, and since we alternate, and even and odd alternate, by definition this should be true. So 0, 0 is up, it is even, and then we go down, the next one should be odd, so down is odd. And then when I plus j is odd, direction is down. Okay, so now we have all the tools we need to solve this problem. There is just one thing to notice here, is that one last thing, which is the sums here, I plus j, go from 0, 1, 2, 3 until 4. And the rows here that we have, the number of rows is equal to 3, the number of columns is equal to 3, the length of this array, which are all the elements, that's m by n, right? The number of rows by the number of columns, which is 4, 4, 8, 9, right? So it should be 9. And so the different diagonal value we have here are 4, right? And so that's pretty much it. So now we can actually start solving the problem. So let's just define our sort and start solving the problem. But let's first actually describe the steps that we are going to take. So the first step, since what we did here is just map the sum to the indices of to the values of the matrix that it contains. So the first step that we are going to do in the solution here which is we can just create a map from I plus j to the values of that diagonal, right? Okay, and then after that, what we can do is that we need to, so when it's up, the i's are decreasing and j's are increasing, and so we need to just reverse the order, right? So, but for example, for up we just get 1. For down we get, if we do the normal order, we get 2, 4. So for down we use the normal order, but for 3, 5, 7, this is the normal order that we will get. We need to reverse it so that we can get 7, 5, 3, right? And so what this would mean here is, after that we will need step 2, reverse order of diagonal I plus j, since that's the key. So this is the map. Let's call the map here diagonals. And so what this would mean here is that we will need to reverse the order of diagonals I plus j. When do we reverse the order? When going up. So 3, 5, 7 we will get, we need to get 7, 5, 3. So we need it when going up, right? Direction is up. Okay, and what direction is up means here is, what we said here is the value is even, which is just when I plus j is even, right? So that's the second step. Now that we have all the diagonals in the right order, we just need to combine them, right? So just combine. Step 3 is combine all the values pretty much into an array. To a list or an array or whichever, whatever we need. And that's pretty much it, right? We didn't use, you can notice we didn't use observation 2. We'll definitely use it in a different solution, but we mainly used observation 1 and observation 3. So let's try to solve this using what we know so far. So the function is diagonal traverse. and we get a matrix as input. And so the first thing we need to do is just initialize the map that we are going to put the diagonals in. So that would be diagonals. We can use collections, right? In Python.default dict. And what we want is for each diagonal values to be a list, right? To be a list of the values here in the diagonal, right? So to do that, we are just going to initialize with a list. Now we can just put the rows and columns numbers in variables here to help us. So the rows are the length of the matrix, the columns are the length of the first row. We'll of course need later to check that the matrix is not empty, right? So that we can just start with check that the matrix, if the matrix is empty, we can return an empty list. And now we need to construct, to do the first step, which is create the map with the keys I plus j and the values being the values in the diagonal. So this would be our first step, which would be just go through the rows. And then we will need the columns here. Then the diagonals, the key, as we said, is I plus j, and we can just add the element, right? So that's the first step to construct the map. Our second step would be to do the sorting here, which is basically reversing the order when the direction is up. And so to do that, we can just go through all the diagonals. And so I plus j values are just rows plus columns plus 1. So we can just do a for loop here. Sorry. So these are all the values of I plus j is possible, right? All the values that I plus j can take are just rows plus columns minus 1. And it's definitely less because, for example, here, but it doesn't matter because the list will be empty in those cases, right? So here it's 4, for example, 4 values we have here. And then now we can do what we said here in observation, because of observation 3, which is when I reverse the order when the direction is up, which is when I plus j is even. And so k here represents I plus j values. And so we can just check if k is modulo 2, which is even, equal to 0, then we need to reverse. So k here iterates through I plus j values, right? And so we can just say, okay, if that's the case, if it's even, then that means we need to reverse the order. So we take the diagonal at that position and we call reverse. And that will reverse all the elements in it. And then in the same loop, we don't need to do like to do another loop to get the values. And step 3, which is just combine all the values, so we can combine right in this for loop. We don't need to do another loop. So let's just create a variable here called res, and every time after we reverse, and sometimes we don't need to reverse if it's odd, but after doing this operation, in case it's even, we can just add, which you can use in Python extend, and add all the values of this diagonal. So and that's pretty much it. And then at the end, we can return the diagonal. Sorry, we can return the result that we constructed here. And that's pretty much it. So pretty straightforward, just put the diagonals in a map. The keys are I plus j, because each diagonal is defined by the I plus j values, since they are the same for each diagonal. And then use the property that I plus j is even. If is even means we are going in the up direction, right, which is what we said here in step 2. And so just check if I plus j, which is represented here by k, if it's even, that means we need to reverse, so reverse. And then we could have done another loop to combine all the diagonal values, but we can just do it here in the same loop. And at the end we return the result, and that's pretty much it for this solution. So the main idea here is that I plus j values are the same for the diagonals in this order. And then since this problem has the alternate directions, we just use the fact that I plus j is even when we are going up and add when we are going down to inform our decision here to know when to reverse. And that's pretty much it. So let's see here what's the time complexity. So if we say that rows are m and columns are n, then what this means is that here we have O of mn, right, because of these two loops. And here we have O of m plus n minus 1, right? And that's pretty much it in terms of time. So this one wins over or takes over this the time here. So overall we have O of mn time. Now in terms of space, we are using this map and we are using this result array. So the map content is at most all the elements in the matrix, and the same thing for res. And all the elements in the matrix are O of mn. So again, O of mn space. Okay, so that's it for this problem. Let's try this code out on some examples and make sure it works. Yeah. Okay, so I wrote down here the solution that we just went through in the overview, with just this, where if the matrix is empty, we just return an empty list, right? Because there are no diagonals there. We define the diagonals map here. This is just defining the rows and columns. We go through each element in the matrix. We put it in the right diagonal bucket, using its coordinates I plus j, which are just r plus c here. Let's maybe just make this I and make this j. And then we go through all the possible values of I plus j. We check if it's even, that means we need to take it in the reverse order, right? Because this is going up. And then we take the reverse order, and then we, at the same time, we collect the values in result array here, or result list, and we just add on all the values in the diagonal in the result. If it's odd, we don't do anything, we just add them as they are. If it's even, we reverse and then add. And that's pretty much it, what we saw in the overview. Now if we run this, all test cases pass. I have a couple of test cases here, but should work with any matrix. And yeah, so that's it pretty much for this solution. We can improve it a little bit or change the way we handle it, so let's take a look at that. Okay, so we can change this a little bit here using dequeue, which allows us to add elements to the front and to the end, right? So that we can avoid this reverse operation here. So we can just use dequeue here. So dequeue data structure. And then here, instead of waiting until another loop to do the check if even, we could just check here. So if I plus j is even, then at this point we can append on the left side, right? So append from the start, which will give us the same result as reversing. Add from the front basically, and here we add from the back because we want the normal order. And now we don't need this, we can just extend like that. And this should work fine. And this case is fast still. Now another improvement we can make here is, instead of doing this for loop to do the extend, we could change this a little bit, and instead here just use reduce, that is in functions tool that Python gives us. Other languages have similar things, so we can just use reduce, and reduce allows us to pass, for example, the diagonals. So reduce allows us to pass the diagonals values here. Those are the ones that we want to combine, right? But what we want here, what is the function that we want to combine them with, right? So we get x and y, and we want to combine. So x and y here are just a two list from it. Reduce takes every two values here. And the function that we want to combine them is just summing lists together. So if it's 1, 2, and 3, 4, it would be one list of 1, 2, 3, 4, right? And we could just return that. But reduce gives us an iterable, right? It doesn't give us a list, so we need to convert that to a list. And if we run this, it should work fine still. And it does. So this is just a variant of how to write this using taking advantage of DQ data structures that has append left function, and then we can use reduce here instead of this for loop that does actually the same thing, right? Okay, cool. So now let's take a look at a second solution that we can do here. So one thing to notice here is that from our observations here for the first diagonal, it's just 0, 0. But if we look at the second diagonal, it's 0, and then the I and j are reversed after that. For third diagonal, we start out, it's just as if we were going down, but reversing the order. So if we were going down, we will start with 0, 2, 1, 1, and 2, 0. But if we just reverse I and j, swap I and j, here, if we swap I and j, we get 0, 2. Swap I and j, we get 1, 1. Swap I and j, we get 2, 0. So we get the same order if we swap I and j from up as if we were going down, right? Same thing with 1, 2. We just swap the order. We get first 2, 1, and then 1, 2, and that way will be as if we are going down. So this is the main idea we will use here, along with the fact that I plus j, the values are increasing. So we get 0, 1, 2, 3, 4. So using these two things that I plus j values are increasing, and then that if going up, so going up is like, so if going down, that's ij, going down, that's I and j, and then going up, that's like we take j and I, right? And so since going down is odd, and this is even. Basically, I plus j is even when going up, and I plus j is odd when going down, right? So along with this, we can just create a sort function and sort I and j values using that sort function. So custom sort function here. What that function can do is sort using I plus j first, right? And then for each diagonal, so sort using I plus j first. Then for each, so this is just sorting the diagonals. Then for each diagonal, sort I and if add, sort using ij, right? That's the going down. And then if even, sort using ji, right? Just the reverse. And if we do this, then just use this to sort the entire matrix. So we can just use this function to sort matrix coordinates, right? So we'll end up with I and j sorted in the exact order the diagonals should be in. And from there, just take the matrix. Ij for all these I and j that we have in the sorted order here, right? And that's pretty much it, right? Okay, so let's see how we can write this function here. So in Python, we could do def here, let's say sort diagonals key. And let's say we get a tuple here that is just I and j values, right? This is what we want to sort with. So the key function here in Python, we could just return pairs, and it will first sort by the first element and then sort by the second, right? When the element is equal. So I plus j is equal for all the diagonals, but we want to first sort the diagonals in the order of I plus j because we have 0, 1, 2. And so the way to do that is just say first is I plus j, and once I plus j is equal, we will need to sort by this second sorting for the diagonal itself, which is if it's odd, we want to keep it in its order, right? ij. If it's even, we want to sort it by so that it's j and I, the reverse, right? So to do that, we can just say if I modulo I plus j is even, right? So that's modulo 2. Then at that point, let's just write it in a Python way. So what that would mean here is it's ji if I plus j modulo 2. So let's just confirm here. I plus j is even. We need, so we need ji, right? Because I is sorted, so we need ji. That's what we've done here. Else, so if this is equal to 0, else we will need ij. And that's pretty much the function that we will use. And then at the end, we could just sort using that function. So what that would mean here is that in our bigger function here, this is diagonal traverse. So we will need to, so now we have the diagonal key, the sort key. We can just, first we will just do the check for matrix empty. Just return empty list here. Then we will need to just do the same thing, get the rows and columns length. And then after that, now we can get the diagonal indices in the right order we want, which is by sorting them using that sort function, diagonals indices. So that would be, we want the sorted I and j indices, right? So I and j. Of course, I is in the range of rows, and j is in the range of columns. But we want these sorted, right? So what is the sort key? So when you do sorted, you can pass a key. So the key that we want to sort them by is the sort diagonal key. And that would get past the tuple I and j, and so that's why we get them here. So the diagonal key. And once we get the diagonal indices, it's easy to obtain the matrix in that sorted order of the diagonals. To obtain, sorry, the list in this order. So now we have the order done. We could just return a list of matrix I and j by taking the I and j in the diagonals indices. And that's pretty much it. So the main idea here is to sort the indices, I and j, the indices of the diagonals, using first I plus j, because that will give us the order for each diagonal. So the first one is 0, the second is 1, the one after that is 2, and then 3, and then 4. So that will give us the order of the diagonals. And then we'll use this second key here so that we can get the diagonals in the right order when going up, and then in the right order when going down. When going up, I plus j is even. Let's just make sure that's right. So when going up, I plus j is even, right? We need ji, and when going down, it's odd, we need ij, and so we do that. There is a small trick we can do here in Python where we could do ji here, like this, and then just do a bracket like this that says I plus j modulo 2. And so if this is even, it will be if this is even, it will be true, and so we'll get ji. If it's odd, we will get ij, right? And yeah, so that's pretty much it. Now let's write this down and just make sure it works with our test cases. Okay, so I wrote down here the solution that we just saw in the overview, which is create the sort key function here. And so that would be first by I plus j, and then by ji if it's even, so going up, and then otherwise it's ij. And then we do the setup here and handle the matrix empty case. And now we get the diagonal indices, which are just the ij indices sorted with the diagonal key here so that we can get the right order of the indices, and then from there we get the values. And so it's pretty straightforward there. Now I'm calling this function here that we just wrote, and then let's just run this, make sure it passes, and all test cases pass. Now let's see just in terms of time complexity, what do we have here? So we are sorting here, and we are sorting mn values. So that would mean sorting an array, right? It's O of n log n, such that n is the length of the array or the length of the list. So here the length is the number of ij variants, so O of mn. So this is O of mn log of mn time. In terms of space, we have this diagonal indices that has at most mn, so that's O of mn space as well. Yeah, so that's it pretty much for this problem. We went over a couple of solutions. There is another solution that we can do that just does the exact traversing. Just goes up, and then when it reaches the end, changes the directions, go down, and then when it goes down, change the directions and go to the next column, and then start going up, which is a little bit more iterative, but you could try it. But these are a lot simpler and easier to reason about. Yeah, so that's it for this problem. Thanks for watching, and see you on the next one.